Good afternoon, and today we're going to be looking at circles, and we're going to be taking an algebraic approach to circles for the most part. We assume that you're familiar in a college level algebra course. We make the assumption that you're familiar with the basic geometry of a circle. You know what a circle looks like. You know it has this point right there in the middle that's called the center. I'll use a C for center. And the distance from the center to the outer edge in any direction is the same. That distance from the center to the outer edge is called the radius. So I'm denoting the center with the letter C, and the radius I'm denoting with the lowercase letter r. Now the center is an ordered pair. The standard ordered pair representation that's used for the center of a circle is h, k. X is the h coordinate of the center, k is the y coordinate of the center. Just like with algebra,
I think you said that. You said x is the h coordinate. H is the x coordinate.
Oh,
K is the y.
H is the x coordinate. K is the y coordinate. Did I say it backwards? Did I say? Well, okay, it doesn't matter. Okay, so we have to know to write. When we're working with taking an algebraic approach, we always have equations and variables. Okay, so with this algebraic approach to circles, we're going to have something called the center radius form for the equation of a circle. To write the center radius form of a circle, you have to know the center and the radius. The center radius form, center-radius form, is x minus the x coordinate of the center squared plus y minus the y coordinate of the center squared equals the radius squared. And that's enough for us to get started with the homework. Looking at number 1. Find the center radius form of the equation of the circle with center at 0, 0 and radius 3. And then part B, they want us to graph the circle. Now realize, to graph a circle, you need to know the center and the radius. They could have asked us to graph the circle and then write the equation. But here they want us to find the equation first. Let me summarize the information they've given us. They tell us that the center is 0, 0. And they tell us the radius is 3.
I'm going to write r equals 3. Look how he summarized it.
Look at how I summarized the information they gave us. The center is 0, 0. The radius is 3. We know center radius form, okay? We have that form right there. And we're going to have x minus, y minus, and over here we're going to square something.
So we're going to plug in
X minus, you take the x coordinate of the center, it's that round 0 there that I have. Y minus the y coordinate of the center, that's the green 0. And on the right hand side, we take whatever the radius is, and we're going to square it. Circles that are centered at the origin 0, 0 are certainly the nicest circles in terms of equations, because x minus 0, that's just an x. So we have an x squared plus y minus 0. That's just a y. So y squared equals 3 squared gives me 9. So notice the equation for this circle is x squared plus y squared is equal to 9. If you're looking at the equation of a circle, you should expect for you to have an x squared and a y squared. So when I look there at that equation, I know it's not a line. Eventually there's going to be some multiple choice questions asking you to describe the graph, and we know this couldn't be a line because of those squares. So, is this the first time y'all have typed exponents? Go to my lab, let's see. Have y'all typed exponents before? I can't remember. Oh, goodness. I type an X, and if you look down there, that third hot button, it can't say exponent. It has to be fancy and say superscript, but you see the little gray box with the little blue box? That's the thing you use for the exponent. And don't type a plus then. Don't type a plus, because that plus should not be in the exponent. Tab or click, do whatever it takes to get out of that exponent. A down arrow, so x squared plus y, hot button, exponent, hot button square, get out of the exponent.
What do y'all think? Do y'all think they're going to give me credit for this, what I've typed?
Certainly not. You have to get out of the exponent position before you type that equals.
Down arrow or right arrow, whatever, equals 9.
Any questions there? So far, not too bad. Now we're going to get to use the circle graphing tool. And this is really such a nice graphing tool. And you'll have to choose. The first thing you have to do is choose the tool. Which tool do you think you're going to be using? You're drawing a circle. There's only one figure there that looks like a circle. Is that the one Tony's pointing at? No, that's a line. Maybe this thing right there? And it's hard to tell, but the center point is in blue, and then there's an additional point there on the edge of the circle that's blue. So that's saying you're going to need the center, and you're going to have to find another point as well. So the center, the instructions say, click the graph to plot the center of your circle. Well, the circle is centered at the origin. So you go to the origin. Is that 0, 0 there?
Yes.
Y'all see where it says it there on the, I need to bring my laser pointer so I can point up on the display. Yeah, but no, you just moved it.
Oh no.
Okay, get it back to 0, 0. There's the center. And now it says to plot another point on the graph. Well, they didn't give us another point on the graph. That's where the radius comes into play.
You know what? I think I may have.
Say cancel.
I think, is my center at 0, 0? I guess it is.
I think I'm going to clear that. Clear it so we can start all over. There. Click. Click.
I don't like all those little bitty grid lines.
Do y'all see the 0, 0 where it says 0, 0? So there it is. Now they want us to plot another point. They didn't give us another point. This is like that old-fashioned compass that you used to use on paper. You put one point at the center, and then you need to put the other point on a point that's on the edge of the circle. To get to the edge of the circle, we know the radius is 3. That means if we move up 3 in any direction, if we move 3 units, we're going to get to the other edge. To the edge of the circle. So starting at the origin, do y'all see where it says 3, 0? It's hard to count there because that grid is so tight. But do y'all see in the yellow box, when he moves that his mouse, the point that he's at is shown in that yellow box. Is 3, 0 on the edge of this circle?
Start at
Yes.
0,
So you
0.
click that point, save it. There, it looks
Oh,
pretty
it's
good.
easier to read off of that, isn't it?
Yeah.
And
And
check.
click. Go back to the circle. I want to point out something. If you had counted, say, Tony counted 3 units to the right, 1, 2, 3. If you had counted 3 units up, you would have still gotten the same circle. If you counted 3 units to the left or 3 units down, you would have still gotten the same picture. Any questions there? The circles centered at the origin are by far the nicest circles, but, well,
It's not difficult.
it's not the ones that are not centered at the origin are the more interesting circles. So here's number 2. Same instructions. They give us the center. The center is at the point -2, 1. And what's the radius?
3 again.
Again? Okay, that's fine. Same instructions. They want us to write the center radius form first. We know center radius form has x minus in parentheses, has y minus in parentheses, and we're going to have a number squared on the right-hand side. Which number is acting like h?
Which one goes here?
Which number is acting as h? Remember, h is the x-coordinate of the center. So which number is h? -2, I agree. So be careful, you have those double negatives now. What number is acting as k? 1, I agree. So we have x minus a -2. Minus a negative, that becomes a plus. So x plus 2 quantity squared plus, well, y minus 1, nothing changes. We just leave it as y minus 1. Hey, y'all didn't tell me what goes on the right-hand side. I forgot about the right-hand side. What number am I going to put here to square? The radius is 3, and 3 squared is 9. This problem highlights something that you need to notice. When you're looking at center radius form, eventually they're going to stop giving you the center and the radius. They'll give you center radius form, and you have to go back to the center and the radius. Notice, because center radius form has that minus sign inside the parentheses. When you're looking at center radius form, the number you see inside the parentheses is exactly the opposite of the center. The x-coordinate of the center is a -2, but what do you see in the parentheses? A +2. The y-coordinate of the center is a +1, but when you look at the center radius form, what do you see in the parentheses? A -1. So the numbers you see inside the parentheses are exactly the opposite of the center. If you want to go back, if they give you an equation and you have to go back to the center, change sign, change sign. That'll give you the center. What are you going to have to do on the right to go back to the radius? What's going to undo that square? The square root. So when they give you center radius form, you're going to have to change sign, take the square root.
Let me type that in.
Okay.
Parentheses.
Left parenthesis, just get the parentheses from the keyboard. X plus 2, your exponent hot button. Get out of that exponent position, plus left parentheses, y minus 1, right parentheses, use your exponent hot button, square, get out of that exponent position, equals 9. And click to enlarge. realize you're not using the equation. To draw a picture of the circle, you need the center and the radius. The center is at -2, 1. And then we're going to have to count 3 units, either up, down, left, or right, to get to the edge of the circle. So, first thing we do, click the circle tool. Then you click the center. The center is at -2, 1.
-2.
Is that it? Is that what he wants? Is that -2, 1? Yes. Now click there. Now just move your mouse. Look as he moves his mouse. It's drawing every possible circle that's centered at -2, 1. Well, we have a radius of 3. That means if we start at the center and we count 3 units, we should get to the edge. He's going to go up now. So he's at 1 plus 3. He better end up at 4. Is that it? Yes. Click that circle. Click that dot. Save the circle, and notice if he had moved 3 units right, 1, 2, 3, he'd be at the same edge, or he'd be at getting the same circle, 3 left or 3 down. It doesn't matter. You count any direction you want to.
Up, down, left, or right.
Any questions there? What you see inside the parentheses of center radius form is exactly the opposite of the center. Number 3.
Boy, I don't like having that same number.
Yeah, don't write this down.
Don't write that down. Let me see if I can get a different.
Different numbers. Yeah, this.
Okay, that's better.
I guess it's better.
I'd rather have the
center.
5.
The center is at 5 -4. And the radius is also 5?
Mm-hmm.
Okay.
Same instructions, write that equation. Isn't it good to start a problem so close to the bottom of the page?
If I were going to need more room than this, I would have started on the next page. So when I start down at the bottom, that means it's going to be short. Okay. What's going to go after the x minus? Okay. Which 5? The green 5 or the blue 5? The green 5, the x coordinate. Okay. What's going to go after the y minus?
Okay.
Well, it's going to be a -4, but it's about to become a positive, okay? Did y'all see that? The formula had a minus, and then we stuck the negative. Minus and negative becomes a positive. What's going to be squared over here? Okay, the radius 5, not the x coordinate 5. It's the radius that comes over here. That's why I'm trying to use a different color for that to show. This is the x coordinate of the center, y coordinate of the center, radius. Now x minus 5, we can't simplify that. We'll just leave it as x minus 5 squared plus that y minus a -4, that became a y plus 4. What have we got on the right hand side? 25. Any questions here?
I have a question.
Yes.
But it was about, I just didn't have the chance to ask it. On the graph, when you're graphing what's it called?
Circle.
Mm-hmm.
The circle, how do you know how wide to make it? I didn't understand too
You're
much.
counting the radius. Whatever the radius is, you start at the center and count that many units, okay? Either left, right, up, or down.
Like on number 2, we plotted the center.
And then we counted 3 units. I think you went
down,
up.
left, or right. It's up to you.
Oh, okay.
Okay,
Plot
whichever.
the center,
3.
and then the radius tells you how many units to move.
Like on number 3, help me out. We're going to plot the center, and then we move how many units either up, down, left, or right. 5.
That's right.
And so as I do that, you're going to decide, do I move up, down, left, or right? It'll be up to
Okay.
you.
Well,
Oh, wait, I got to type
Type.
in this.
left parenthesis, x minus 5, right parenthesis, square, get out of the exponent, plus left parenthesis, y plus 4, right parenthesis, exponent hot button square, get out of the exponent, equals 25.
Now notice you're not using any of that to graph it. Okay, to graph it, you're using what's given to you, the center and the radius. So let's see. Okay. Okay. So let me make that big. Oops, I thought I'd already opened it up. I'll click circle. So the first thing I do is find that center. Oh gosh, what was that?
5, negative 4.
Oh gosh.
The x coordinate is 5.
5.
The y coordinate is negative 4.
Negative 4. Am I at 5, negative 4? Oops, no.
You see it? Yeah.
Yes. Okay.
Right there. So we
Oh,
click.
I think I messed up there. Right there.
Okay.
5, negative 4. Now it's up to you.
Do you want to count up, down,
5,
left, or right?
Up. Okay. So here we go. 1, 2, 3, 4, 5.
We were at negative 4 plus 5. Negative 4 plus 5 should drop us off at 1. So are we at 1 on the y-axis? Yes, we are.
Mm-hmm. And look, if we move 5 units to the left, would it be on
Put
the
it over to the
y-axis?
larger grid, then I think it'll be easier for her to see. Okay. Count 5 units. Once there's the center at 5, negative 4.
2, 3, 4. I just moved 5 units left, or I can move 5 units right. 1, 2, 3, 4, 5.
Or you could have moved 5 units down.
1, 2, 3, 4, 5. Okay.
Any questions there? You're using the radius to get that second point. Whatever the radius is, that's how many units you have to move up. It's up to you, up, down, left, or right.
Good. I don't think I've checked that.
No, you haven't.
Oh, okay. There.
Any questions there? Number 5.
Number 5. 4 is just okay. Okay.
Same instructions. We want to write the center radius form and draw the graph. The center is at 0, negative 1. The radius is 6.
But it's the same old thing.
So realize that 0 is acting as our h and negative 1 is acting as our k. So we have x minus, y minus, what number will go after the x minus? What's the x coordinate of the center?
I heard it.
I didn't hear it. 0, okay. Y minus, what number's going to go after the y minus? Okay, now what's going to happen with that minus and negative? It's going to become positive. And we can clean this up pretty nicely. X minus 0, we can simplify that very easily. That's just x. So we have an x squared plus, that minus and negative, we'll write that as y plus 1 quantity squared. And what have we got on the right-hand side? 36, I agree. For my final answer, x squared plus y plus 1 squared equals 36.
X squared down arrow, plus,
left parenthesis, y plus 1
plus 1, squared, down arrow
equals 36.
36.
Mhm.
Yeah. Yeah.
Let's see about using the larger grid. Let's see what this is like here. I don't know. Where's the palette? Where do you click? There's this. Let's see.
Maybe if you just blow it out, I mean, click right there.
Does that do it?
Oh, well, I think
It's the same thing. Okay, so oh, the palette was down here. Look at this. Let's see something. Maybe this is okay. What do y'all? No, I don't like that. I don't like that at all. You click the circle, and the center is at 0, -1. Is that the center? Am I at the correct point?
Yeah.
Say yes. Yes, okay. And now, Zelda, you're going to help me find another point. What's the radius? 6. So we're going to move. What do you want to do? Up, down, left, or right? It doesn't matter. You'll get the same picture. Up. So we're going to start at this where I'm situated at -1 and move up 6 units. 1, 2, 3, 4, 5, 6. So we're at -1 plus 6. That dropped us off at 5. Is that where we needed to be? Ah! Oh, I'm just there. Oh.
Let's look and see. 1, 2, 3, 4, 5, 6. Yeah, you moved up.
Same thing there. If you'd counted 6 to the right, 6 to the right, or 6 down, save it. I think it's clearer to see here. 1, we're starting at the center. Let's count 6 to the right. 1, 2, 3, 4, 5. Sure enough, there it is. Any questions there? Number 6. Oh, look at this. I warned y'all this was coming. They want us to graph the circle, but they didn't tell us the center and the radius. You gotta have the center and the radius if you're gonna draw a circle. Gotta have the center and the radius. So this is number 6. X, is that a -7 quantity squared plus y plus 4 quantity squared is equal to 9.
Maybe we should look back at that number 3 to make sure.
Yeah, look back here. Hopefully y'all see the pattern. Look at number 2. Remember, what did I say? When you're looking at center radius form, what do you have to do inside the parentheses to get the center?
Change the sign.
Change sign, change sign. What do you do to the number on the right-hand side to go back to the radius?
Square root.
Square root. So, on number 6,
Change
to
sign.
find the center, change sign, +7, change sign, -4. To get the radius, you take the square root of that number on the right.
Change the sign, square root. That's how you find the center and radius.
No.
Is it clear why we're finding the center and radius? How do you graph a circle?
You need to know the center and then use the radius to find another point on the circle.
Y'all remember those little pencil compasses that at least we used to always have to have them in elementary school, where there was a sharp point on one side? Well, you put the sharp point down at the center, you move over 3 places.
1, 2, and then you draw it, sweeping it around. I think they quit those because I think too many people got stabbed with the sharp
I
points.
remember we would poke each other with them in elementary school. That was a bad thing to do, but it's what we did.
I
So,
think I still have mine from, it wasn't elementary school. I remember it in high school.
school
I still have
geometry.
mine in my high school one in my desk drawer, okay?
So if there's
All
ever a
rusted and something.
crazy person going in to kill you, you got your weapon. You can get your compass out from 1980.
1981.
Whatever.
Okay,
Okay.
yeah.
Click. Hey, you know what? Let's just try this, Tim. If you want to try using this, what if we did this?
I don't
Oh,
think
I
I'll
can't
let you
make
go
it any
smaller.
smaller.
Mhm.
And no, I think we're going to have the whole thing like that.
Okay, you click the circle. The center is at 7, -4. So right 7, down 4. Is that 7, -4?
Ooh,
No.
7,
There. Click it.
3.
Now we need one other point. The radius is 3. It's up to you how you count. I think Tony wants to count up.
No, I want it to go right.
Right,
1,
1.
2, 3.
And he gets right there at the edge. He was at 7 plus 3. Now he's at 10.
Y'all agree with
Click
that 3 point? Or you could have moved up. Sounded like you wanted to go up, or
I was
left,
gonna
or
go
down.
But
Let's
either way,
look
we
at
get
it
the
over
same
here.
picture.
So we plotted 7, -4 is the center, and then I moved right 3, but up 3, left 3, or down 3, however you want to do it. Any questions on that? And is it clear how we got that center and radius? That changed the sign square root. That's important.
Number 7.
Oh, wait.
Oh,
There. Not number 7.
same instructions. Okay, x plus 4 quantity squared plus y plus 3 quantity squared. Today they're really hung up on 9, aren't they?
Well, they want this last number to be a perfect square, and they don't want it too big. You don't want 144. Oh my gosh, I got to move over 12 units on this little bitty grid. So,
Yeah, you're right. A radius of 3 is almost an ideal radius, I suppose, for our purposes. What's the center? I'm not saying anything. I'm waiting. -4, -3, I agree. Radius, you take the square root of. Take the square root of 9. So the radius is 3 also.
and hopefully it's clear why we're doing that. It doesn't say anything about find the center and radius.
But you're not going to draw the graph for the circle unless you have
The center.
the center and the radius.
You've got to have that center and radius, and it doesn't matter how you're drawing the circle. If you're using paper and a compass, you still got to know where to put the sharp point and how far over to move. So, I'll come over here, click to enlarge, gonna graph a circle. So start off with the center.
-4, -3.
-4. Oh, am I -4, -3?
Right there, don't move it.
Uh-huh.
And now we have a radius of 3. I'd move 3 units to the right, because if you move 3 units to the right, you're at -3. So move 3 units to the right. Isn't that dropping you off on the y-axis?
Time I moved 3.
No, that would have been up, okay? You moved 4 there, didn't
Oh, I
you?
did?
You're at -4.
Oh, I did. Okay.
Yeah. I guess I should have moved up.
1, 2, 3. Now did I move over
That's
3?
it. Yeah, that's it.
I'd started at -4 on the x-axis. If I'm going to move to the right 3, I'd be at -1. Or if I'd move to the left, I'd be at -7. No.
Now moving up 3, that gets us on the x-axis right there. That would have been a good way to do it. Okay. Transfer it to our grid.
You can
Notice
see
it's
it
still 3 units.
One,
Odds
two,
favor your
three.
radii are not all going to be 3. It seems like every one we've done up here, our radii have been 3. Radii is plural for radius. The different radiuses all seem to be winding up as 3. I don't know why. That doesn't normally happen. I guess radii sounds better than radiuses. That sounds stupid, doesn't it?
Mhm.
I see why they use radii as the plural. Any questions there? Well, it can't stay this simple forever, right? I want us to consider, I guess I'll just use number 7. We're through with number 7, but I want us to consider the equation x plus 4 quantity squared plus y plus 3 quantity squared is equal to 9. Center radius form has those nice binomials being squared and the square of the radius over on the right hand side. Suppose someone wanted to remove the parentheses. X plus 4 squared is not just x squared plus 4 squared. That means x plus 4 squared, that's x plus 4 times x plus 4. What are we going to have to do to multiply x plus 4 times x plus 4?
Foil.
We have to FOIL that out, aren't we? Plus y plus 3 squared. That means y plus 3 times y plus 3.
See, we've been writing the equation with the parentheses and leaving it like that.
Suppose someone went through and removed the parentheses.
Foiled
They
it out.
expanded the step by FOILing out the x binomial, FOILing out the y binomial. The equation we're going to get, as it is, when it's in center radius form, it's easy to get the center and the radius. Change sign, take the square root. Suppose someone went through FOILing all this stuff out and combining like terms. Do you think it'll still be so easy to get to determine the center and the radius? Let's see. Let's FOIL out x plus 4 times x plus 4. First, x times x is x squared. Outer, x times 4 is 4x. What's inner? Move your mouse so they can see what I'm writing. What's the inner product going to be? Another 4x. What's the last? Last times last? 16. So that reduced to x squared plus 8x plus 16.
Use red, that way it'll really
Plus,
stand out.
use red for the y now. First, y times y is y squared. Outer, y times 3 is 3y. What's the inner product going to be?
3y.
Another 3y. Last times last? 9, I agree. Let's suppose we decided to get this thing set equal to 0. Let's get that 9 and move it over. That means that positive 9 would become a minus 9 equals 0. Or expanding center radius form. Well, y squared plus 3y plus 9, that's...
No, plus 3y plus 3.
Y squared plus 3y plus 3y, that's going to become a y squared plus 6y plus 9. We still have that minus 9 equals 0. Now, let's write the terms in descending order and combine the like terms. We have some constant terms that are like terms at least. So we're going to have an x squared. Well, we have an x squared and a y squared. They both have the same exponent. Let's make them, let's put them in alphabetical order. So we have x squared plus y squared. Now the 8x,
Nothing to combine to fit.
the 6y, 16 plus 9 minus 9 is just a coincidence. Those numbers both turned out to be the same. But that would be a 16 plus 9 minus 9. That's just a plus 16 equals 0. This form here that I've written in is called expanded or standard form
For a circle,
for a circle.
which I don't prefer.
There's really no time. The only time I can think when you might want to, when this is desirable, I think if I were looking at an implicit differentiation
Yeah,
problem, I think it might be nicer here.
Calculus. Oh, yeah.
Yeah, from a calculus point of view, this might be the better form, okay? But from an algebraic point of view, can you just look there and tell the center's -4, -3, and the radius is 3? With this expanded form, can you easily look and determine the center and the radius?
Like here it was easy, the way it was
Yeah,
written on number
change sign, take the square root. It's easy when it's in center radius form. But when it's in expanded form, do you see you can't just look and determine the center and the radius? That's bad. If they give you an equation in center radius form,
No, expanded.
I mean, it's an expanded form, and they want you to graph it, you're going to have to get it written back in center radius form. So that's what you're going to have to do. Take the expanded form and convert it back to center radius form. That when you look here, when you're looking at this expanded form, well, I guess I see a 16 right there, okay? X squared plus 8x plus 16, that factors as x plus 4 times x plus 4, hence the x plus 4 squared. But there's not even a 9 appearing here. It's these numbers right there, that 16 and that 9. That's the problem. We don't have that 9, for instance, appearing. We don't have the 9 there appearing in the center radius form. So what we're going to have to do is take the x terms, group them together, create a trinomial like this, x squared plus 8x plus 16. That's called a perfect square trinomial. It factors as variable plus or minus a number squared. And so we're going to have to take those x terms, create a perfect square trinomial, take the y terms, create a perfect square trinomial, and then get the constant term by itself on the other side. Before we do anything else, I think we need to just practice with perfect square trinomials. Here's an example. X squared plus 8x plus 16. We said that that's the same thing as x plus 4 times x plus 4. In other words, it's an x plus 4 squared. Center or standard form. Another perfect square trinomial, that red one, y squared plus 6y plus 9. That's a y plus 3 times a y plus 3. If you FOILed it out, if you factored it out, you get y plus 3 times y plus 3, which is the same thing as y plus 3 quantity squared. Here's another example of a perfect square trinomial. X squared minus 10x plus 25. How would that factor? X squared, we know that's x plus x.
Or just x and x.
X times x. The last sign's a plus. That means you have what inside the parentheses? The last sign's a plus, you have two of the first signs, so a minus and a minus. For 25, what are you using?
1 times 25 or 5
5 times 5? And 5x and 5x, yeah, that'd give you the 10x, and that would factor as x minus 5 quantity squared. If it's a perfect square trinomial, the last number must be a perfect square. If I'd had 17 here instead of 25, then we wouldn't be able to factor it as a binomial squared. Also, look at center radius form. Center radius form always starts off with an x in the first parentheses and a y in the second parentheses. When you're foiling those things out, x times x, should you get a 5x square or a 3x square, x times x will always give you what? Just x squared. Likewise, y times y is going to give you a y squared. So you better not have some number in front of the x squared or the y squared. If you do, we'll have to deal with that, and it's not that bad. Let's see, I'm going to make up another perfect square, then I'm going to have y'all help me make perfect squares. How about x,
Oh, wait.
oh no,
Maybe.
x minus, no, x squared minus
16x.
16x plus,
Hey, does anyone have any idea of what number would have to be there? It's a perfect square.
what
Yep,
number? Here's an observation you can make. X squared minus 10x. Notice, in expanded form, you had the x squared and the 8x. You had the y squared and the 6y. So I like Tony's idea. You have the x squared and the x. What number's going to go there?
It's got to be a perfect square.
Look at this. I see a 10 there. What number did we use in the factorization? That 6y, what number did we use? The 8y,
8x.
the 8x, what number did we use?
64.
She's answering the
I
right.
think I like the way you're thinking. You need a 64. How did she come up with 64? Look at what happens to create a perfect square. You do 2
8 times 8.
Okay, where'd you get the 8?
From 16.
It's from
Okay, from the 16, you take half of 16. 16 divided by 2 is 8. And then you square the 8. 8 squared gives you 64. And then that's going to factor. I'm going to skip the x minus 5, this stage here. I'm going to go directly to the stage with the exponents. How will that factor as a perfect square trinomial? I'll get you started. It's going to be an x. What sign will we have inside those parentheses? A minus. And then half of that number was 8. If you FOIL out x minus 8 times x minus 8, you're going to get back x squared minus 16x plus 64. Notice this one here. Looking at the 6, half of 6 is 3. 3 squared is 9. That's where that 9 came from. Let's do another one.
y square. Use y square.
Oh, that just gets messy. X squared minus 20x plus, what number would I need to turn this into a perfect square trinomial? What number would need to go there? We want it to factor in the form x and whatever that sign is there, so minus. What number, what perfect square goes here? 100. I agree with your logic. 20 divided by 2. Do y'all see the pattern? Whatever the coefficient of the unsquared variable is, you take half of that. That gave you the 10. And then 10 squared gives us 100. What number's going to go here when we're factoring it? X minus 10.
Maybe it'd be a good idea to write out both of them. X minus 10 times X minus 10.
If you wrote out x minus 10 times x minus 10, if you FOILed it out, you get back x squared minus 20x plus 100. This process of creating perfect square trinomials is called completing the square. The process of creating perfect square trinomials is called completing the square. We could have completed the square to solve equations, quadratic equations, at the beginning of the semester, but I said completing the square works best with circles. So I said we delay seeing it until we got to circles. Now we're at circles. I have a handout for you in my bag.
Mm-hmm. Plus
Here.
Thank you.
what perfect square would need to go into this box or this little blank in order for it to factor like that? 81. Did y'all hear that? I'm going to write out how you're getting it. Whatever this number is right there, that middle number, you take half of it and then square. Half of 18 is 9. 9 squared, 81. But 81 doesn't go here. What goes right there? 9. And you can think of it as either the square root of 81 or half of 18. And you know what it looks like I have right here? Does that look like a decimal point?
Just scribble it out.
Oh yeah, that's going to make it look a lot better, let me tell you. There.
Well, you could always use your erasable pen.
Oh,
Pens.
I think I brought those home.
Does everyone have one of these things? Okay. Let's see.
I think they can do one with that. I used to do number 8 without reading the sequence.
Okay. I like that idea. I like the way you're thinking, Tony. Just let them think about it, right?
Oh, shut up, Tim.
Okay.
Okay, do y'all see the biggie? How does number 8 differ from number 7?
Number 7, you can look there. Change sign, take the square root. Simple. There's the center and the radius. Look at number 8. Someone went through and expanded it. They got rid of the parentheses. We have an x squared plus y squared minus 12x plus 2y. Oh, they left the 27 on the right-hand side. That's fine.
But it says find the center and radius. Well, it's easy to find that center and radius when it's written with those parentheses. So we're going to go backwards. We've got to write it with the parentheses now.
Okay, first thing you do, let's group the x terms together. We have an x squared minus 12x. X squared minus 12x. We're going to have to add a number there in order to create a perfect square trinomial. Now let's group the y terms together. We have a y squared plus 2y, and we're going to have to add a number there. And on the right-hand side, we have 27.
But wait, are you going to add a red number on the left?
Yes, I'm going to add a red
Then
number on the
you have
left.
to add a red number over here. So put a red blank.
I like that. Okay. We're going to add a blue number on the left. So we're going to maintain the balance, we're going to have to add it to the other side also. So we have a blue blank on the right also.
So if we could keep going, it would be plus blue blank over here, but it's on a different line.
No,
Okay.
that's okay.
Let's figure out what perfect square
What perfect square goes in this red block, in this red space here?
36.
Okay, I agree. You take half of 12 is 6, and then you square the 6 to get 36. So you put 36. You just added 36 pounds to the left side of one of them old-fashioned scales. If you added 36 pounds to one side to maintain the balance, you have to add 36 pounds to the other side. And that brings up an important point. Realize, for it to be a perfect square trinomial, that last sign has to be plus. Think about when it's being FOILed out. Negative 10 times negative 10 gives you a positive 100. Those signs inside the parentheses would have to be the same. So that last sign there has to be a plus. You couldn't have a minus 36 there, or it wouldn't be a perfect square trinomial. What number is going to go into the blue blank?
Half of 2 is?
Half of 2 is 1. Half of 2 is 1. And then 1 squared is still 1. So we add 1 pound to the left. We add 1 pound to the right. You have now created 2 perfect square trinomials. Let's factor them. Let's factor the x
Your
ones.
goal, you're trying to make it look like that center radius.
Center radius form has to have the binomial square with an x plus binomial square with the y equals. Okay, y'all tell me, how is this going to factor? The x squared minus 12x plus 36. Variable, what sign will I have here? That minus, a variable, sign, what number? 6. Variable, whatever that first sign is, half of that number. So x minus 6 quantity squared would FOIL back to give you x squared minus 12x plus 36. Now let's do the y terms. How will they factor? They're going to factor as a quantity squared. Variable, y, sign, plus, half of that number was 1. Over here we have a 27 plus 36 plus 1. 27 plus 36, is that a 63 plus 1? 63 plus 1 gives me 64.
Oh gosh, I hope it's clear why we did that. Can we look and tell the center and radius now?
Now that the equation's been converted to center radius form, what's the center? 6. 6 negative 1.
So you went change
sign, change sign. And to get the radius, you take the square root of that number. The square root of 64 is 8. If your equation is written in expanded form, and you need to draw a graph of it, you're going to have to get it written in center radius form to determine the center and the radius. To get it in center radius form, you'll have to complete the square for x's, you'll have to complete the square for y's. Any questions there? I know it's a lot to absorb or to take in right now.
I hope we haven't been timed out. Let's see, I'm now going to try to, in order to draw the circle, I must know that center. And what is the center?
6 negative 1.
Negative 1. Am I at 6? Oh, that's, oh shoot.
That's
Now,
6 negative 1. Now you're at 6. So let's see, 6 negative 1. Let's go up 8 units. Your position at 6 negative 1. So if you're going to go up 8, negative 1 plus 8 should end up at 7. Is that it? 6, 7?
oh, right.
Nope. There it is.
So I moved up 8. I could have moved left or right or down. It's easier to tell it from here. Okay, let's see.
Oh, it's incrementing in units
I
of
know, that's
2.
why it was so hard to tell. Do y'all see that 1 is midway between here? So this little point here
That's
is
6. Oh, you know something?
6, -1.
Mm-hmm.
Let's just move right. 2, 4, 6, 8.
Right there. So you get the same graph.
Uh-huh. I'm going to check it. Is it clear why we were doing that? In order to find the center and radius, you've got to have it written with those parentheses.
Okay.
Here's another one. This one we'll do faster.
No, we're going to look at the handout I gave them.
Oh,
Okay, switch to the camera.
again, before videos, there were handouts.
The center of the
A
equation
lot of
for a
leaflet.
circle centered at 0, 0. We saw that with problem number 1, didn't we? It just became x squared and y squared.
Moving it too much, it's
Wait,
sort of blurry. Hey, wait, I'll just do this. I'll
No.
blow it up myself. You
I'll
know?
do it myself.
Oh.
There. Is that better? There.
So imagine way back in the olden days before the videos
Okay,
and
let's
stuff,
see.
this
Here.
little handout was
Okay,
designed.
Tony.
Well, I
Let's
mean,
keep
they're
going.
probably wondering why you're giving them this little sheet of paper saying what you've already said. And it was
Okay.
recorded too.
So there's the HK. When the center is HK, there's center radius form. To find the center and radius of a circle, change the sign and the number paired with X. Change the sign of the number paired with Y. Yeah. To find the radius, take the square root of the number. I think we said all of that. Change sign, change sign. So the center for this first example would be +2, -5. You take the square root of 49 to give you 7. Okay, well, let's see. I think we've said all of that. Oh, look at this, though. Here I have the steps for completing the square, and there's something I have written here that we haven't encountered yet. It says to rewrite ax squared plus ay squared plus cx plus dy plus e equals 0 in standard form. If a doesn't equal 1, divide each term by a. Earlier I said, if you're squaring x times x, you're going to get an x squared. You're not going to get a 3x squared or a 5x squared. If they have a number in front of x squared other than 1, and that does happen in the homework, there'll be a number where the problem where there's something, maybe a 2 or a 3 in front of the x squared, you're going to have to divide every term through by that a value. You need the x squared and y squared coefficients to be a +1. Then group the x terms together, followed by the y terms. That's what I was doing here, grouping the x terms together, the y terms together. Isolate the constant on the right. Let's see, divide the coefficient of x by 2. 12 divided by 2, that's what I did right here on my scratch paper. That's a 6. Then it says square the number found in step 3. 6 squared is 36. Okay, we add the 36 to both sides. Add that number found in step 4 to both sides. We put the 36 and the 36. Repeat steps 3 through 5 for y. That's what we did here. Half of 2 was 1. 1 squared was 1. Add 1 to both sides. Factor as perfect square trinomials. That number 7. Factor, and at that point it should look like it's in center radius form. And let's see, something I'm going to do here. There's something important here at the bottom. What's going on?
I'm zooming and you're...
Okay. To find the center, change the sign of the number in the parentheses paired with x. Change the sign of the number paired with y. We know that. Number 9. To find the radius, take the square root of the number on the right-hand side. And so far, that number on the right-hand side has always been a positive number. If it's a circle, it has to be a positive number. Suppose you got it in center radius form, and this number over here, suppose it had been a negative. Suppose instead of a 64, we'd had a negative 64. You try to take the square root, what would that be? What sort of number would you get when you take the square root of that negative 64? The square root of a negative is imaginary. If r is imaginary, r equals the square root of a negative, then there's no graph, not even a point. Now, if this number over here turned out to be 0, you'd have a center. 6, -1 would be the center. But what would the radius be? When you took the square root of 0, what would happen? It'd just be 0. So if r is equal to 0, the graph isn't a circle. It's just a single point. And we'll see that happening along the way. But now I think we're ready to do another one. Number 9. X squared plus y squared minus 4x plus 8y minus 16 is equal to 0. The instructions just say graph the circle. In order to draw the graph, we need to know the center and the radius. So we're going to have to complete the square to get this thing written in center radius form. I'll group the x terms together. X squared minus 4x plus, skip some space. I'll group the y terms together. Y squared plus 8y plus, skip some space. We need that constant term over on the right-hand side. So the 16, that negative 16, we'll move that over. That becomes a positive 16. But we're going to have to add the green number to the left side, and we're going to have to add the brown number to the right side also. Group the x terms together, skip some space. Group the y terms together, skip some space. Move the constant term over, and whatever those other two numbers are that you're going to add, you're going to have to add them to the right side also.
How do we find the number that goes in the green box?
I'll get you started. You start with 4. You have to do two things. What do you do with that number 4? Divide it in 2. 4 divided by 2 is 2. Then what do we do with the 2? Square it. So you get a 4. You're going to have to add 4 to both sides. What are we going to add in beside the y squared plus 8y? I'm not going to say anything.
What number goes in here?
16, I agree. You take the coefficient of y. Half of 8 is 4, and then you square 4 to give 16. If you're adding 16 to the left side, to maintain the balance, you have to add 16 to the right side. Any questions? It's that step right there. Creating the perfect square trinomials. What number do you add to create a perfect square trinomial for x? What number do you add to create a perfect square trinomial for y? And then they're going to factor very nicely. What's going to go inside these parentheses? Variable x, it's that first letter you see. Sine That's that first sign you see, minus number 2. It's half of that number there. You could also think of taking the square root of the number you added in, but to me, I just go left to right. Variable sign, half of that number is 2. Plus, let's factor the y's. Variable, y, sine, constant, half of 8 is 4. And we have something real nice on the right side. What number do we have on the right side? 20 plus 16, 36. Is this going to be a circle? Will this graph be a circle? Can you take the square root of this number and get a radius? It's this number over here that decides if it's a circle. If it had been a negative 36, you can't take the square root of negative 36. You get a 6i. You can't count 6i units. So in order to be a circle, this number must be positive, and it is. What's the center? Change sign, I agree. The radius, you take the square root of 36, which is 6. So this equation is a circle centered at 2, negative 4 with a radius of 6. Any questions there?
Let me try to graph it. Click here. Circle.
What was that center? 2, negative 4.
So right 2, down 4. I'm at 2, negative 4. Yep.
And now radius of 6.
Okay.
You're at 2 on the x-axis. Move to the right 6 units. What number will that drop him off at?
On the x-axis.
On the x-axis, 2 plus 6 drops him at 8. Is he at the correct point? Yes. There's the graph. And notice, if he counts 6 units in any direction, he gets to the edge of the circle. Check answer. Any questions? Number 10.
It's a multiple choice. Like that.
The center and radius of this, find the center and radius. Here they're not asking us to draw a graph. That's nice. 4x squared, but there's something I really dislike here. Now think about
What's different about this one? Don't say multiple choice. No. The equation.
The equation, there's something about the equation that's different from, say, number 9 or number 8.
Did you write it down?
Yeah.
9 is a symbol.
It's not a simple.
The way they have that 4 there, that looks like it's not a simple trinomial. We need a 1x squared. That's what I said here on this handout. A is the number in front of x squared and y squared. If a doesn't equal 1, you're going to have to divide every term by a in order to get it looking like numbers 8 and 9. So whatever that, and realize, if you have a number in front of x squared, you have to have the same number in front of y squared for it to be a circle. If you wanted to change that to a 4, instead of 1x squared, if you wanted that to be a 4x squared, you'd have to distribute the 4 all the way across, which means you'd have a 4 on the front of the y squared also. So if you have a number in front of x squared other than 1, you'll have the same number in front of y squared. And it's a simple problem. Simple enough solution, I should say. Divide through by whatever that number is.
That's what step 1 on your little handout said.
Divide through. If the number in front of x squared is not 1, divide each term by that number. Now, why do we do that? Because it's now going to start canceling out. Where's my blue pen? There. 4 divided by 4, that's an x squared plus y squared plus 32 divided by 4 is 8x minus, here what will we have? Okay, 16 divided by 4 is 4y plus, is that 19? 76 divided by 4 is 19 equals 0 divided by 4. I always have someone say undefined here. No. Remember, 0 divided by a non-zero constant k, that's okay. That's equal to 0. 0 divided by 4 is 0. Now, number 10 looks like number 9. So we're at the same spot we were when we started number 9. We'll group the x terms together. X squared plus 8x plus, skip some space, plus, we have a y squared. What else do we have here beside the y squared? Minus 4y plus, skip some space. And on the right-hand side, we move the 19 over, so that's a negative 19, but we still have to add the green blank and the red blank. What's going to go in the green blank? X squared plus 8x plus 16. 8 divided by 2 is 4. 4 times 4 is 16. So we put the 16 here and there. What's going to go in the red blank? Okay, 4 divided by 2 is 2. 2 times 2, I agree, is 4. Any questions on our logic there? 8 divided by 2 is 4. 4 squared, that's where we got the 16. 4 divided by 2 is 2. 2 squared gives me back a 4. So now we should be able to factor these as perfect squares. Let's factor the x terms. Variable, sign, plus number. Okay. Variable, sign, half of that number. Now the red terms, you call it out. Variable, sign, minus, number. I agree. Variable, the first thing that's being squared, that letter's the first letter there. That sign is the first sign, that first sign is the sign in the parentheses. Half of 4 is 2. And look at what we got on the right side. I don't think it could work out nicer. Negative 19 plus 20 gives me a 1. That's a positive number, so we know the equation's a circle. We know it's a circle because it's positive. What's the center of the circle? Negative 4, comma. Okay, remember, change sign to get the center. To find the radius, you take the square root of 1, which is just 1. So we're looking at a circle centered at negative 4, 2, with a radius of 1.
Look at the choices.
They all say radius 1.
Okay.
Negative 4, 2, is that C?
See?
So we don't have to draw this graph. Okay, that's good. Okay. Number 12. Number 12. Hey, on number 12, are we going to have to divide the way we did on number 10? No, because look, we already have that x squared and y squared. This is number 12. X squared plus y squared plus 2x minus 6y plus 14 is equal to 0. Let me make sure I don't miscopy that. So y squared plus 2. Hey, look at those possible answers. Look at option C. I know option C cannot possibly be correct. Option C says the graph is of the equation is a line. Do lines have x squares and y squares in them? If it didn't have if the x squared and y squared were gone, if it were just 2x minus 6y plus 14 equals 0, it'd be a line. But those x squares and y squares guarantee that it's not a line. I think they just wanted 4 options there. That's why they have that condition. I mean, that option that the equation is a line. But we know it's not going to be a line.
Why don't you refer to that little thing?
Look back over here. Zoom in a little bit. Okay. Now, if we go through and we get a 0 on the right-hand side, meaning the radius is 0, then in that event, the graph will just be the center point. That's what they're saying for option, where is it, B? The graph of the equation is a point. That means that the radius turns out to be 0. Well, look at option D. The graph is non-existent. Well, right here, if you're trying to take the square root to get the radius and it's the square root of a negative number, that means there's no graph, not even a point. So that would be option D. Whoever wrote that answer, rather than saying the graph doesn't exist or that there is no graph, they wanted to be fancy. The graph is non-existent. Well,
Wait, so we're going to start?
Yeah, I'm going to get started now. Ooh, and zoom it. Here we go. Group our x terms together. X squared plus 2x plus, skip some space. Now we'll group the y terms together. Y squared minus 6y plus, skip some space. What have we got on the right-hand side? Here. What am I going to write to the right of the parentheses? Negative 14. You have to make sure the constant term's over on the right-hand side, but you still have 2 blanks. You're going to have to add in the blue blank and the red blank. Actually, I guess this is more like a teal or a turquoise or whatever, this color, but it looks blue under the camera. What number's going to go into the blue blank?
1.
I couldn't hear you.
1.
1, I agree. 2 divided by 2 is 1. 1 squared is 1. Put 1 in both blanks. What number's going to go in the red blank? 9. 6 divided by 2 is 3. 3 times 3 is 9. So we can factor. Factoring the x terms, what will I have inside the parentheses? X plus variable sign half of that number. I agree. What's going to go inside the red parentheses? Y minus, okay, variable sign half of that number. Things look like they're going along great, don't they? Negative 14 plus 10. Ooh, that looks like a decimal point. It's just a 14. Negative 14 plus 10. Look at what we have on the right-hand side. What's the problem? That negative, when you try to take the square root of -4, that would give you 2i. You have an imaginary circle. There's not a physical circle. You can't draw it. It is meaningless. There is no graph. Not even the center point. If you think about it, no matter what you plug in here for x, when you square it, it's not going to be negative, because a number times itself is not going to give you a negative result. So non-negative plus, no matter what you plug in for y, when you square it, it won't be negative. Non-negative plus non-negative. Positive plus positive. Can that give you a -4?
Positive.
Positive plus positive. You plug in any number you want to for x or y. When you square all of that, it's going to be positive. Positive plus positive. Can it equal a -4? Can it equal a negative anything? No, y'all don't seem convinced. It doesn't matter what you plug in for x or y. When you square the results, it'll be positive plus positive equals a -4. That cannot happen. There's no point in this situation. There's no graph, not even a point. You would choose option D. The graph is non-existent. Any questions there? Have the strength for another one? Have the attention for another one? I'm going to do another one. That's a bad habit. I shouldn't be asking that, because then they may say, no, we're just going to go. I want to do another one. Number 13, x squared plus y squared minus 4x minus 6y plus 13 equals 0. Realize you can't just look and decide, oh, it's not going to be a circle or something until you get it into center radius form. You can't just look there and say, oh, it's not a circle, or
all you can do is look and say
it's not a line.
But
You know it's not a line because we have x squares and y squares.
So we can't choose A. If you're going to guess, don't guess at A.
Okay. Let's switch to my paper. Group the x terms together. X squared minus 4x plus, skip some space. Now what am I going to do? What will I do next? Right, group the y terms together. Y squared minus 6y plus, skip some space. What have I got on the right-hand side? -13, I agree. And we still have the blue ball, the blue spot and the red spot. What number's going to go into the blue space? Half of 4 is 2. 2 squared is 4. Y'all following my mental arithmetic? You take half of 4 is 2. Then you square it. 2 squared gives us 4. So 4 goes on the left-hand side. It also goes on the right-hand side. What about the red space? What number's going to go there? 6 divided by 2 is 3. 3 squared is 9. How will the blue terms factor? X minus, okay, I agree. There's a pattern for these factoring. It's whatever that letter is. X sine minus half of 4 is 2. How will the y terms factor? Y minus 3. Variable sine half of that number. What have we got on the right-hand side? Negative 13 plus 13, I agree with the 0.
Do we have a circle?
No. If you try to find the square root of 0, it's just 0. We do have a point, though. The point that we have is the center. What's the center?
2.
2, 3. So imagine this graph. 1, 2, 3, 1, 2, 3. You go to the center, 2, 3. There's the center. How many units up, down, left, or right are you going to move? 0. All you have is just the center.
Just that little point.
That center point, 2, 3. If you plug in a 2 for x and a 3 for y, you get 0 plus 0 equals 0. That's the only point that satisfies that equation.
So let's see, what option is it? A, B, C?
Oh, they're not making you state the center.
I
All
thought-
they say, I know I saw some publishers, they do, but this one
Doesn't.
it mustn't be.
Maybe
Mhm.
2 is-
If they asked you what is the point, it's whatever the center is, okay? But I'm pretty sure I didn't put them on there on the
No,
side.
okay.
So the
Just
graph
point.
is a point, and there. Have y'all got the hang of it? This is the last completing the square problem, but we could go back and do number 11.
You want to do number
14
11?
and 15 are just old material, but
Quadratic
y'all think y'all want to see one more? We have time. Let's do number 11. Okay. Just so we can say we did all the completing the square
They might
problems.
think you don't know how to if you don't.
If I don't, well, they probably think you don't know how to. That's why I'm doing all the writing today.
Oh, okay.
X squared plus y squared plus 8x plus 4y plus 11 equals 0. So just tell me in general, you've run into this problem, you need to find the center and the radius. What will I do first? What am I going to do first?
Group the X.
Okay, group the x terms together. X squared plus 8x.
Group the x's, put a plus blank.
And now what am I going to do?
Group the Y.
Group the y's. I agree. Y squared plus 4y.
Blank.
What have I got on the right-hand side?
Negative 11.
Negative 11. And I still have a black blank and a red blank that I'm going to have to fill in. Okay, what's going to go beside the x's? X squared plus 8x. What number am I adding here?
16.
Okay, 8 divided by 2 is 4. 4 times 4 is 16, so I add a 16. What am I adding into the red blanks?
4.
Half of 4 divided by 2 is 2. 2 squared is 4, so add 4. And let's factor the x terms. What will I have in the parentheses?
X plus 4.
X plus 4, I agree. Variable, sign, half of that number. Now let's factor the y terms.
Y
Y
plus
plus
2.
2, I agree. Whatever the letter, that first letter is that you see, whatever that first sign is, half of 4 is 2. What have we got on the right-hand side? Negative 11 plus 20. I agree with the positive 9.
Is this a circle, a point, or
Or no
non-existent?
graph. It's a
It's a
circle
circle. How
because
do you know
that
that?
number is positive. So the graph is a circle. What's the center of this circle?
-4,
-4, comma, -2, I agree. What's the radius?
square root of 9.
Square root of 9, which is equal to 3.
So after class, if someone says, what did Mr. Timothy Precella teach you today? You say, change the sign, square root.
Change sign, change sign. Change sign, change sign, take the square root. One day, when I'm old and confined to a nursing home, that's one of those phrases that I may not remember what I had for breakfast, but I'll be sitting there. Change sign, take the square root.
And if the second sign is plus, 2 are the first. If the second sign is minus, 1 plus and 1 minus.
And people will walk by and they'll be like, what are those two old men mumbling? They're remembering their teaching days. There are certain phrases we say over and over until my dying day. I'll remember that. Now, I may not remember what I ate for breakfast that morning, but I'll remember. Change sign, change sign, take the square root.
Let me see if I can make this a little smaller so I'll get there. Okay.
So you choose option A, you enter in the circle, the center, you enter the radius, check answer, and there.
Well, it was sort of a long one. 14 and 15, what are they? Probably quadratic formula, some sort of
that's cut point.
Oh, cut point. They love those cut points, don't they? Okay. Any questions on this?
And we still have class on Friday.
No,
on Wednesday. We have class on Wednesday.
Spring break doesn't start until around 4 on Wednesday. And you said, what about my other classes? I don't care about this other class.